They gave you r equals cosine theta. They want you to find dy over dx. Now that is essentially the slope of a tangent line. So that's the complicated one. It's not the easy one where you're finding r with respect to theta. If they would have said, hey, find the rate of change of r with respect to theta, the answer would be r equals negative sine theta. That's it. You found a derivative. But I want this to be represented as a slope of a line like x and y sort of thing. So let's start with some basic stuff. We will use the black pen this time. X equals r cosine theta, which is cosine theta, that's r, times cosine theta, so that's cosine squared theta. Y is, I was about to skip some space, let's not. R sine theta, which would be cosine theta, sine theta. Okay? And we are going to find the rate of change of y over the rate of change of x, so let's shift gears for a second. Let's switch colors too. Green sounds good. Dx d theta is, okay, chain rule here. This would be like u squared, so that would be 2u times the derivative of cosine in this case, so that'd be negative sine. That's it. And then dy d theta would be, well, product rule on this thing, so f prime g, so negative sine times sine, that'd be negative sine squared, plus f g prime, the derivative of sine would be cosine, so that makes it this. So final answer, switching colors again. I'm just enjoying writing way too much here. Dy over dx is, and you could have kind of skipped this step and jumped straight over here, but it's going to be this one over this one. If you find them in the order I found them in, where you find the dy last, then make sure you put it first. It's easy to mix them up because we usually do x first, but in the slope y is on top generally. So negative sine squared theta plus cosine squared theta over negative 2 cosine theta sine theta. Yeah! That question's done. Let's move on to the next one. Determine the polar coordinates for the horizontal tangent lines. Stop right there. Hold that thought. Where are tangent lines horizontal? Glad you asked. I'm gonna clarify this question over here in parentheses. The numerator equals 0. Now, there's a little caveat to that. The numerator can equal 0, and if the denominator equals 0 too, then you have a hole in your graph, and yeah. So the numerator equals 0, and I do want to just check, at least in my head, that the denominator is not equal to 0. Just saying. Okay. So let's go blue on this one. I want this numerator, whoops, to equal 0. I could set the entire thing equal to 0 and multiply by the denominator and it would go away, right? But yeah, let's not. If you're like, how do I solve this? Well, don't panic. Really, don't panic. What I'm going to do is just move one of these terms over. So I'm going to move the negative sign over. That's going to give me cosine squared equals sine squared. And I'll square root this. And when I do, I end up with all kinds of fantasticness. I'm going to end up with cosine theta equals, well, sine theta when you square root it. But when you square root, you have the option of positive or negative. Okay, so this is the question really then. Like you're thinking, well, how do I solve? Don't panic. Don't panic. You got this. I'm thinking where on the unit circle, I almost said where in the world. Let's just focus on the unit circle. Where are cosine and sine the exact same? Let's ignore the plus or minus for a second. Where is cosine equal to sine? That would happen here at pi over 4. It also happens here at 5 pi over 4. And at those values, at those radian measurements, we have sine and cosine as the same, and they would both be the square root of 2. Whoops. No. Okay, that's not theta. Theta is my answer, and it would be pi over 4. Whoops, I went too far. However, the values here would be square root of 2 over 2, comma square root of 2 over 2. Same here, only they're both negative. Okay, getting ahead of myself in something, and I apologize. So we're gonna deal with that in a second. All right, so pi over 4, comma, chameleon, there are going to be 4 answers, and if you don't put them in the same order I'm putting them in with these awkward gaps, that's fine. But I also need to consider where cosine is equal to negative sine. So basically they are the same number with the opposite signs, and that's going to happen in the other 2 locations. It's fairly obvious in this case. That would be 7 pi over 4 and 3 pi over 4. And so 3 pi over 4 and then 7 pi over 4. There's that. So those are my theta values. Okay, let's stop for just a second, and I'm going to check something. I want to make sure my denominator never equals 0. So these are the theta values that make my numerator equal 0, but do they ever make a denominator 0? And the answer to that is no. So if I plugged in any of these theta values, I would get square root of 2 over 2 or negative square root of 2 over 2 for sine or cosine. That will never make my denominator equal 0. Now, if one of these answers would have been pi over 2, yeah, we'd have a problem. Pi over 2 is equal to cosine of pi over 2 is equal to 0. The whole denominator would be 0. Yeah, couldn't do it. This is not an issue right here. It's just good to check that at least in your head. So let's actually answer the question, and I'm going to use red for once. Determine the polar coordinates for the horizontal tangent lines. Now, if you want to get technical, this could go on another cycle and another one, but we're just going to stick to 0 to 2 pi. So we are going to have 4 answers. How do you know there are 4 answers? Because there are 4 answers. Because I said so, that's why. Now, polar coordinates are always listed as r and then theta. Okay, so polar coordinate, that would be r comma theta. And I found theta. It's pi over 4. Or 3 pi over 4. Or 5 pi over 4. Or 7 pi over 4. An odd number over 4, essentially, pi. Odd number pi over 4. And then if I plugged in pi over 4 into what? Into what? Into this. Into this. Determine the polar coordinates for the horizontal tangent lines of this function. This is the function. Now, if you're like, well, how do I know I don't plug it into the derivative? Then you'd get 0, which is the point, actually, right? That's where these came from. So I want to plug it into the original function. So cosine of pi over 4 is the square root of 2 over 2. Cosine of 3 pi over 4 is negative square root of 2 over 2. Cosine of 5 pi over 4 is... Sorry, my brain just shut down for a second. Negative square root of 2 over 2. I'll tell you what I was thinking in a second. And then right here, this would be positive square root of 2 over 2. So here's what I was thinking. I was like, oh no, did I make a mistake earlier? And I was thinking, oh, cosine's positive here. Yeah, it is. And so I was thinking that I had said something wrong, but I didn't. So I'm going to backtrack and walk you through a thought process. Both sine and cosine are positive here. Both sine and cosine are negative here, which would still work for this. And I was thinking, oh no, I said the wrong thing. Cosine is positive in this quadrant and this quadrant. Sine is positive in this one and this one, but they're both the same sign in that one. So sorry for that awkward explanation there where I got off track. Let's slide up. Determine the polar coordinates for the vertical tangent lines. Vertical tangent lines, oh, okay. Vertical tangent lines. Tangent lines are vertical where, and I think we need to write a little bit, this would be where the denominator equals 0, but the numerator does not. So if the denominator equals 0, then we would have a slope that is completely vertical, but if we had 0 over 0, then we would not have a function at all that existed at that point. So I do want to say that the numerator cannot equal 0 at all. So determine the polar coordinates for the vertical tangent line. So same idea, we're just going to set the denominator equal to 0 using a blue pen, of course. And this is going to get real fun, so check it out. We're going to set this thing equal to 0. And when I do, I could divide by 2. So then I would divide by 2, and I would have cosine theta, sine theta equals 0. So cosine theta equals 0, sine theta equals 0. Let's limit this to just 0 to 2 pi, and including 0 but not 2 pi. So cosine would equal 0 at pi over 2 and 3 pi over 2. And sine would be equal to 0 at 0 and at pi, and at 2 pi, but let's not get crazy with it. So we already have some answers. Now, again, if I plugged any of these in to the numerator, I would not have, well, we'll cross that bridge in a second. I was about to get ahead of myself, but yeah, we'll just run with it. So 0, nope. Oh no, and my whiteout's not whiting out. Oh no, it's still not whiting out. No, the whiteout's not working. All right, we have 4 coordinates, and sorry I was getting a little scattered a moment ago and was getting ahead of myself again, but we're gonna, let's run through a thought process. Here's the thought process. If I plugged in pi over 2 to the numerator, would I get it equal to 0? No. If I plug in 3 pi over 2 to the numerator, would the whole thing equal 0? No. What if I plugged in 0? No. Pi? No. You'd get a term to equal 0, but you wouldn't get the whole thing. Therefore, I don't have this situation. That's what I was going to say earlier, but I went ahead and wrote down the 4 coordinates. Sorry, I'm a little scattered right now. Let's keep moving. So pi over 2, 3 pi over 2, 0, and pi. And where are we going to plug them in? Determine the polar coordinates for the vertical tangent line, polar coordinates of that function. So cosine of pi over 2 is 0. Cosine of 3 pi over 2 is 0. Cosine of 0 is 1. Cosine of pi is -1. All right, last one. Determine if the graph of r of theta is increasing or decreasing at that value. So here's what I'm going to do. I want to decide if, switching colors again, that was my decision breathing. Yeah, that's it. What color shall I pick? Orange. And by orange, I mean purple. So here we go. Let's write with this orange pen. dy dx. I want to determine if the slope is positive or negative. And when I get an answer, I'll know if it's increasing or decreasing. All right. So let's plug this in to this. I think it's totally okay to kind of shift gears here and switch to a calculator, just for the sake of simplicity in what we're doing. And we could plug in the pi over 2 to all these and figure things out. I'm going to be in function mode. Well, shouldn't you be in polar mode? I don't want to be. Shouldn't you be in parametric because that's how you take a derivative? I don't want to. I have everything I need right here, kind of as a function in a sense. So y equals, clear out all the other stuff that you have, and let's type negative sine theta. And whoops. I'm going to put some parentheses on this thing. That's it. Plus, and then I need parentheses again, cosine x, and then square that whole thing. And then that'll close out the numerator. Parentheses get out of hand here. -2 cosine x, and then sine x, and that closes out the denominator. And I'm going to double check. There's my denominator. It's good. My numerator is also good. Parentheses are in the right spot. We're good to go. Make sure that negative is outside of the parentheses that you're squaring. Otherwise, it would, well, have the wrong sign. Someone wanted to say bye. All right. I don't know if y'all heard that, but it's in the hall, someone's like, bye. Anyway, 2 pi over 3 is going to go in as the x value in this case. So, trace. Pull up that function, and we're going to plug in, 2 pi over 3, and I'm about to get a number, and that number is this, right there. When I plug this in, I have a negative. Okay, that's good to know. I grabbed the wrong color pen. I didn't go through the thought process where I make the awkward sounds. There we go. So there's that, which is negative, so r of theta is decreasing at theta equals 2 pi over